Hello, everyone. I wanted to go through a few things that I think you should be made aware of before the exam. Just been looking through the exam and again, and I'm going to cover a couple things. Actually, one particular thing I think I didn't cover too well, and also make you aware of all the things that you have not been tested on so far. So, first thing is okay. I wanted to go through. There's a particular example of electric field drawings that I don't think I covered too well. Now, the idea is, okay, we got for example, we got two parallel plates. Okay, so most people are pretty good with drawing these. You would have uniform field lines going from positive to negative, and you can draw the edge effects as well. Okay, now, but what happens when you put a uncharged spherical conductor inside that? Well, immediately in the presence of the field, you have it's uncharged, so you have, but is a conductor, so you have electrons are able to move. So what you end up with is electrons will move, will locate near the top, and you end up with positive on the bottom. Because electrons have drifted from here to there. Delocalized electrons of the metal. Okay, now what does the field look like on the outside of that? Well, remember you should draw your field lines such that they meet conducting surfaces at right angles. Something to this effect. You've got field lines here that will distort a bit. Side. You get less of that effect happening further you go away, and then it kind of returns to being uniform. If I drew this a bit longer, you'd end up with uniform field lines, and then you end up with the curvature effects because at the end here. Same, yeah. Negative. What's a negative? Okay, so something like that. I've drawn it, so it's not quite centered. So right into the way I've positioned it. Okay, now the thing is about in the middle. Now I think I might have not done this very well. Immediately you think, okay, well you got negative charges and positive charges here. Wouldn't there be an electric field going inside there? Well, the thing is, there's no. It's a bit like the argument into why there's no parallel component to electric field along conducting surfaces. The idea is basically inside here is zero, and the reason for that is essentially there's two fields. There's the field of the plates, which if this was not a conducting surface, you just have field lines just going straight down, and you got the field which is created by all these charges drifting, such that the electrons are more electrons on top and less electrons on the bottom. So what that does, it ends up with a total net field of zero. And the reason, and kind of the reason for that is, well, these charges now that I've drawn here are now stationary. If there was a field inside here, or inside the conducting surface, then those charges would be still moving because they'll have a force acting on them. So the net field has to end up being zero. So yeah, there's no field inside. And that's what's happened here. Now, a couple other things. Okay, just scanning through the exam quickly. So you got all the topics covered. So projectile motion, uniform circular motion, gravity and satellites, momentum, electric fields, magnetic fields. Anyone, if you listen to this, that probably means you've been checking your emails, so you'll be aware that you can have access to your tests. I've scanned them, so if you want them, send me an email. I'm just not going to send them out in bulk if people aren't checking their emails. Okay, so stuff that you haven't been tested on so far. So Now, the structure of the exam, I should also mention, the exam has the long and short answer questions that you use to for your tests. It also has a practical component where you're basically data analysis, where you might have to manipulate some variables. You've got some data, and you have to modify that data in some way such that it will tell you, like, okay, you might need to square root something, you might need to times it by this, or square it, or whatever it happens to be, or find the inverse in such a way that we know that it will form a linear, possibly proportional line of best fit. And then you need to graph that data and generally do something with the data, like, so sorry, with the line of best fit. So the line of best fit usually ties to something else. So for if anyone's curious, I can set you some questions, but I don't have my books in front of me, so I would have to manufacture that myself. But yeah, okay. So, all right. As far as the other topics now, so topics you haven't been tested on is like so electromagnetic waves. So you need to understand the idea of the topics not yet tested. But in the exam. So we didn't do EM waves in the last test because we finished at charges in moving charges in magnetic fields. So electromagnetic waves. So you got anything from the generation of waves, the wave equation. You've got all that stuff, and you've got particularly the LADs. So there's extended response questions. So you need to be familiar with all the applications in each chapter. So LADs is a good one for that. Interference. Okay, so the exam, the content of the exam, so EM waves, you got the spectrum, your wave equation, got polarization. You got the LADs, the laser airborne depth sounder. Make sure you go through that. Now, interference, not everything in interference. Young's double slit is where you end. I mean, you will be essentially assessed on these at some point, but just giving you warning about what will definitely be covered. All right, so things in interference where you've got the idea of coherence, interference, the two extremes. So the path difference being multiples of lambda implies constructive. That's assuming you start with coherent source, of course. And you got path difference of m plus a half lambda is destructive. And understanding the whole double slit apparatus, why you need that single slit to start with. What else I think is particularly important? No, I suppose that's it. Just yeah. So topics not covered. Go through this again. Electromagnetic waves, which is everything from understanding the different parts of the spectrum, the wave equation, polarization, and the application, the LAD system. Very important. Interference is okay. So the chapter, everything that goes up into and including Young's double slit. So to explain Young's double slit, you need to understand coherence, you need to understand path difference leading to interference, and you need to understand the Young's double slit interferometer itself. So that Okay, so that's just a little reminder of what you need to be aware of that we haven't tested you on. So if you've got any questions, send me an email, and I might make another one of these, because some of you are asking to catch up to do your pracs, and you may find me around next week. But otherwise, I'll leave it there. So just keep checking your emails, and just keep studying. And if you've got any questions, make sure to let me know.